Hello, everyone, and welcome to the final day of KubeCon. Today, we're going to be doing a deep dive on HashiCorp Consul and some of the features around the service mesh that it provides. My name is Jono Sosulska. I'm one of the developer advocates here at HashiCorp, and I'm really excited to be able to go through what we're going through today. With me, I have Derek Strickland. Before we get started, I just want to go through and remind everyone that we are broadcasting to YouTube, so please ask your questions. Derek, mind introducing yourself?
Yeah, sure. Thanks, Jono. I'm Derek Strickland. I'm a Consul education engineer focusing on the Kubernetes ecosystem. I've been with HashiCorp for most of this year, and I'm excited to get in here and show you some of the amazing things we can do with Consul Service Mesh on Kubernetes.
Awesome. Well, let's dive right into it. Show us what you got, Derek.
Right, let me get my screen share up and running. And so, first of all, welcome. Thank you so much for taking time out of your schedule to come see us today at KubeCon. We are going to today go through a migration of a monolithic REST API to a microservices architecture, and we're going to leverage the services of the Consul Service Mesh to do this in as non-disruptive a way as possible. So that's going to be the use case we work through today. So before we get started with all that, I wanted to take a second to show you the smiling faces of the team that made this possible. These are all the managers and leads and engineers that built the solution, that built the integration with Kubernetes for the Consul platform. And I would be remiss if I sat here and presented this to you as if it were my work. These are the folks that make the magic happen. And then that's me down in the corner. I focus on bringing you the consumable educational content. So thanks for joining us again. So let's get started. Let's talk about our objectives. By the end of the demo today, we want you to be able to understand what a config entry is. A config entry is a term in the Consul world, and it has a meaning and a purpose, and we're going to talk about what those are. And we're going to talk about the different use cases for the different types of config entries. And then we're going to show you a great new feature of Consul 1.9, which is currently in beta. Previously, config entries were managed through the Consul CLI. We've now exposed them as CRDs, and you can natively manage them with kubectl using your natural Kubernetes workflow, and we're really proud of that accomplishment. So we're going to show that off a bit today. Then we're going to deploy a sample app to Consul on Kubernetes, and we're going to talk about it. We're going to talk about its weaknesses, and we're going to extract a microservice out of a monolith that exists within that sample app. And then we're going to do a canary rollout to see how we can do that using service splitting safely. And we're going to do all that with CRDs from kubectl. And so let's dive right in. The agenda is, first go over the config entries themselves, then deploy the app, extract the microservice, route some traffic to the new microservice, then perform a canary rollout. And we'll do a couple of iterations on the canary rollout, increasing the volume of traffic we send until we finally cut over to it solely. And then I'll give you some next steps and resources so you can do further research on your own. So config entries, let's talk about those for a second. Config entries are a way to configure global settings or individual service settings within the service mesh, okay? And we currently have 6 types of config entries that can be managed as CRDs, and we're gonna talk about each of them. And they will all get covered in this particular demo, except for service intentions, which is a new feature in Consul 1.9. We have a whole Learn guide on how to use those. And so I'll talk about them briefly, and I'm listing them here for completeness sake, but that will be the one type of config entry we don't cover in detail today. So let's just dive right in and talk about each one. So first of all, we'll talk about Proxy Defaults, which is a global configuration setting for the entire service mesh. And what it does is it allows you to inject your own desired configuration into the Envoy sidecars. If you're not familiar with Consul Service Mesh, we integrate deeply with Envoy as our proxy. We ship with a configuration that we provide, but we allow you this sort of escape hatch approach to injecting your own Envoy configuration if you need to. And this is a global setting. And previously you would have had, with all these config entries, you would have had to use the Consul CLI to inject these into this configuration into the control plane. But now you can use kubectl directly and just write YAML instead of any other configuration format. So that's a big UX improvement in 1.9 that we're proud of and want to show off here today. So in this particular situation, I'm injecting a Prometheus bind address into every one of the Envoy proxies so that I can get metrics from each pod running within the mesh. So that's what we're going to use Proxy Defaults for today. The next type of service entry, or config entry that I want to talk about is service defaults. A service default, in fact, affects an individual service. So the metadata name there, you see it says product API. That'll be your service name that you want to affect. And you have a lot of different settings that you could set. But in this particular situation, we're just going to affect the protocol, and we're going to set them all to HTTP. We want that because we want to be able to manage our services using some of our new L7 features. And our L7 requires, obviously, that you run the HTTP protocol for the service rather than the default TCP protocol. So as each one of these services gets registered, we're going to go ahead, with the exception of Postgres, we're going to go ahead and set its service default protocol to HTTP, and we can just do that with this YAML. All right, and then a service router is another type of configuration entry that you can apply to the service mesh. Again, you target a specific service, and then it allows you to match on different things like query string, header, etc. In this case, I'm matching on a path prefix, and what I'm going to do is I'm going to use this router, this service router config entry, to intercept traffic that's coming to the product API service. And if it has a specific path prefix, I'm going to reroute it to a different destination service. So that's what a service router does. It allows you to reroute traffic from one service to another. So we also have another type of config entry that we're going to use here, and it's part of the Canary rollout use case that we're going to illustrate in the second half of the demo. And it's called a service splitter. So a service splitter, what it does is it says, okay, for this given service, again, it targets a specific service. And it says, for this specific service, I'm going to define some subsets, or I'm going to route to some different subsets, and I'm going to weight the routing, or I'm going to split traffic with a given weight. So looking at this YAML, you can see I'm going to send 90% of my traffic to service subset V1 and 10% to V2. So this is one of the mechanisms that we provide to allow you to do a Canary rollout. And then you can just iterate on updating the weights until you're satisfied and move on. So a service resolver is another type of config entry. And this sort of works in concert with the splitter that we just saw. Notice the splitter had a subset stanza that was targeting different subsets. Well, what's a subset? A subset is a concept within, or a configuration within the mesh that the resolver provides. And it says, hey, if something's targeting subset V1, the filter to find all the V1s of the coffee service is that this service.meta.version has been set to V1. And I'll show you how we do that through pod annotations here during the demonstration. V2 obviously works the same way. And then the final config entry that we're going to explain today, again, this will not be illustrated in this demonstration, but you can check out our Kubernetes custom resource definitions tutorial on Learn, and it will show you all about how to use this. And it's called a service intention. And what it is it's an extension to the L4 intentions we've had for quite a while in Consul. And what it does is it allows you, to apply new L7 filter criteria to allow or deny traffic between two services. So you could match on the absence or presence of a header. You could filter, allow or deny traffic based on the absence or presence of a query string, etc. So that's a really powerful feature that allows you to, and you can do all that, by the way, inside the Consul UI. You don't have to use the command line to achieve that. So that is a massive improvement in 1.9 that I want to point out. So let's go ahead and talk about our deployment of our sample application. So this is a conceptual diagram of the application we're going to deploy. There's a graphical user interface that's going to run as a pod. There's a GraphQL API that can speak to multiple backend services. In this demo, it's only going to speak to this REST product API that is a CRUD-based veneer on top of our Postgres SQL server, but it also does some other things. We'll talk about that when we get into the application explanation. But here's the conceptual diagram of how traffic flows to the system, what's inside the service mesh, et cetera. And then the ingress gateway illustrates how in a production environment, you would let users into your mesh. So to provision the environment, so that you understand exactly what we're working with today, you need a Kubernetes cluster. I personally am running Kind on my local machine. This could all work, of course, in any cloud provider or with other local Minikube, K3s, K0s, et cetera. So I've pre-provisioned my environment to a point because a couple of these steps might take a minute or two to run, and obviously we don't want that dead air here for you to experience. So I've done some of the longer running steps up front. The first thing I did was I created a cluster, and then I installed Consul using a config file, which is well documented on Learn and our Consul.io developer docs. Then I went ahead and installed the Prometheus operator. And then the last thing I need to do is configure the proxy defaults to set up the Prometheus bind address that I mentioned earlier when going over the proxy defaults config entry type. So that's actually where we're going to start with our live demo. And that's the command that we would have to run to install the defaults. And once we run it, we'll inspect it. So let's go ahead and do that. So just by way of, I've got my screen split up here just to give you some orientation. I've got a couple of long-running log tails that I'm going to want to show to you throughout the demo. And I've also got some port forwarding I'm going to do. So I've got a small terminal window set up for all those long-running operations, but the main commands will be performed in the center, the very wide center area. So let's go ahead and jump in. The first thing I'm going to do is apply those proxy defaults like we discussed. So again, using kubectl natively, I can just apply the YAML. There's no, which is a major improvement in 1.9. That wasn't an option previously. So now I can just do what you would expect. I can get my proxy defaults. Well, there they are. I can also describe them and kind of make sure everything got updated the way I expect. And oh, look, there we go. My Prometheus bind address is there. So that's great. So that's a big improvement. Let's stop and celebrate that for a second, because in previous iterations, you would not have been able to do that in a Kube native way. You would have had to figure out a way to configure a console client to talk to the mesh, et cetera. So I want to stop and clap it up for the Consul Kubernetes team and the amazing work they did there. So our proxy defaults have been applied. Let's go back to our demo, our slide deck for a second. And we'll talk about the application we're going to deploy. It's called Hashicups, and it simulates a basically an online ordering app for a coffee chain. And the application, once it's deployed into Kubernetes, it looks like this conceptually. You'll have your control plane that's talking to your data plane. Services are inside of pods that run on a node. There's a console client on each node. There's an Envoy proxy sidecar and a life sidecar next to each service. And for today's demo, we're going to talk just about this REST API. The rest of this, which talks to the Postgres database. We're going to talk about it because it's got some problems. Right now, it's very monolithic. Any calling client that hits that service could be calling it for 3 different reasons currently. They could be calling to get a list of products for a public page where they would want to see, what can I buy here? They could be calling to log in so that they can actually order. And then they could also be calling that monolith to place an order, view previous orders, cancel an order, et cetera, et cetera. So those are three very different concerns that are all sort of lumped together. And oh, by the way, I don't have it illustrated here, but payments also are currently routed through that monolith. So not relevant to this conversation, but the point, just to sort of stress the point, it's a monolith that needs breaking up. We've outgrown it, right? We need to be able to iterate independently on each one of these services. Some of them are interrelated, for example, auth and orders, right? Because orders are behind the login. So you've got to authorize first. If you're not authorized, orders has to send you back to auth. If you are authorized, it has to validate your session and make sure you're still authenticated and authorized. And so there's just a lot of complexity there and interrelationship there. Payments, similar situation. Products, though, they're interesting. So they're in front of the login. We don't really care if you're logged in to see our products. We want you to see our products, and maybe that'll invite you to, entice you to create an account and log in and start buying, right? So when we look at this problem domain, if we want a quick win for this proof of concept, maybe our organization doesn't believe in microservices yet, right? So our best chance of convincing folks to adopt this approach is a quick win, right? So we're going to go with the products area because there's no authentication involved and there's no interrelation with other layers out of the gate. It's just a query service essentially, right? So that makes it the obvious candidate. So because that's what we're going to focus on, I'm just going to take, I'll explain that in a second. Let's talk about let's go ahead and deploy our application while we're here. And then we're going to visualize it inside of Consul's UI. So
real quick, would you mind increasing the font there so that way we can see all the commands that you're running?
Sure. Let me see if this is that popping.
Yeah, there we go.
Okay, thanks. Just quickly let me read. All right, great. So I've got all of my application inside of a HashiCorp directory. So I'm just going to apply that. And now that it's out there, I'm going to run another job. Actually, before we do that, let's get it over here and I'm going to forward my Consul UI port so that we can view the Consul UI in a browser and look at our service mesh visualizations. So just a second while I type. I think that's going to work for it. Oops. That's supposed to be SVC. Great. So if we go back to our browser, and I'm going to drop out of presentation mode for just a second here so that we can see this cool UI. And we're going to come over here and I'll just give it a quick refresh now that I've restarted my environment. And apologies, the Docker and Zoom are notoriously resource intensive. So things are still spinning up. The Postgres layer isn't quite there yet. The public API is still spinning up. Oh, Postgres just came online. Public API should come online in a second. There we go. So before we do anything else, let's just stop and look at this for a second. We've got all of our services, and going back to that conceptual diagram, things start at the front end. The flow of traffic through the mesh starts at the front end. So another new thing that's happened with Consul 1.9 is we've added metrics into the topology diagram so that you can see traffic flowing through, and Prometheus is the metrics provider we're integrated with here. So that's pretty interesting. Also, you can check out your routing inside the UI now and see, maybe what routing configuration has been applied to a given service. That's going to get more interesting in a little bit when we start doing service splitting, et cetera. So what's also nice is, if I start at the front end, I can see that it's connected to the public API. I can just click on that, and it takes me, it reorients itself with the public API as the central figure in the chain, and I can see what its upstreams and downstreams are, and I can just sort of click through the whole flow of traffic until I get to the terminal point, which is the database. So that's pretty sweet. So we stop and clap it up for the design team and all the visualizations that they did. They've added in this release of Console 1.9. Super cool, but it's going to get better. The next thing I'm going to do, and I probably should have done this a second ago, so forgive me if it causes just a little bit of lag, but I want to deploy another pod, and its job is just to sort of hammer the back end with some traffic. It's just a traffic simulator, okay? So we've got a couple of different things going on inside of our mesh currently. So let's just look at it while that traffic job is spinning up and generating traffic. Let's look at what we've got going on. We've got our console layer, right? All the different console related pods. We're seeing our application and Prometheus. Everything's running. The traffic pod is not quite up yet. Oh, yeah, there it's running. So let's go back to our console UI and make sure everything agrees over there. Oh, 1 second. There we go. So here's let's go back to our all services list. And there you go. There's our load test. It's running and it's hitting the front end. And oh, look, it started to generate traffic. So that's pretty cool. We can see requests per second, et cetera, error rate. And then we can also hover over the graph and look at specific points in time. Notice the timestamp's changing. I've got a solid, consistent load running in my traffic simulator. Obviously, in reality, it wouldn't work out that way. But that's pretty sweet. We didn't have that before. So I'm going to stop and celebrate that for a second. And then when I get over to the public API, I can see, oh, it's doing the same thing. I can see the traffic here. I can do the same thing on the product API. And then over at Postgres, we can see some interesting metrics, data received, data transmitted. It's using the TCP protocol, so its metrics are slightly different. So I'm going to come back over here to the product API, and I'm going to stop right there. I'm going to leave this screen up for when we come back. And then I'm going to do something else. I'm going to start watching. Let me grab a code snippet, if you don't mind, from my handy dandy cheat sheet. And what I'm going to do is I'm going to set up just a tail on the logs, basically, so that I can watch the log traffic in real time. And that's going to get pretty useful when we want to see traffic getting rerouted around the service mesh, right? So let me find that log script. Oh, here we go. So we're going to go ahead and watch the products API's logs kind of stream in up here in the top left corner. Okay. So we're going to watch that, and it'll take just a second to get started. But there we go. The traffic job is doing its job, and traffic's hitting the service like we'd expect, and that matches up with what we see inside the console UI. So that's pretty cool. So what should we do next? Well, if we go back to our agenda, I think the next step, we'll go back into presentation here for you. We viewed the traffic in the UI. And our next step will be, guys, to extract the microservice. So we talked a little bit about that before. This is just as a quick reminder of what the current state of the union looks like. And we're gonna remove the orders and auth artifacts from the diagram. on a move forward basis, just to give ourselves back a little visual real estate. So moving forward, if you don't see them on the subsequent slides, that's why. And we're just going to talk about the service that we're going to peel off. So what we're going to do is we're going to add a microservice called Coffee Service. Why are we calling it Coffee Service? Well, one of the things we discovered when we looked at our products API is that we don't serve up any products out of the products API other than coffee currently. So we're going to improve our design by correcting a naming problem. And then if we have other products beside coffee, maybe they need their own microservice, right? Maybe they need a nice, tightly bound context, so to speak, right? In DDD terms. And so we're gonna set, the first thing we're gonna do is we're gonna configure our service with a service default protocol of HTTP. We're gonna do that before we deploy the service. Why are we doing that? Well, when you create a service default, inside under the hood, there's a controller that we have running inside of Kubernetes that is listening to the event stream. It sees that you want to create a service default, and then it creates it for you. Well, if we published that at the same time as our deployment, there'd be no guarantee that the service default got applied prior to the deployment getting brought up, right? Because everything's declarative and it's up to Kubernetes to just ultimately, eventually reconcile the environment the way that you want it. So it creates a little bit of a race condition where the service could come up prior to the service default being registered. And then the default protocol is TCP, and that wouldn't be the configuration you wanted. So just a little quick pro tip, make sure to configure your service defaults prior to deploying your services. The next thing we're going to do is we're going to publish a deployment, and that's just a standard Kubernetes deployment that looks at a Docker image and deploys it. But we're going to apply some annotations that are interesting for this this demonstration to that deployment. Number one, we're going to set the Prometheus scrape to true. So it tells the Prometheus operator, hey, pay attention to this pod. We're going to set the IO port that Prometheus is publishing metrics at. Then we're going to set the console connect inject annotation to true so that we tell console, hey, pay attention to this pod or this deployment. And then we're going to set an upstream because as we illustrated in the diagrams earlier, the Postgres pod is an upstream of this service. So we've got to let this service know, hey, this is your upstream and this is the port to talk to it on. And then we're also going to apply a service meta version annotation. And if you remember back at the beginning, I was pointing out the service resolver had a filter, right, that would look for a meta version equals v1 or meta version equals v2. And that's going to help us in the future as we do canary deployments in the second half of the demo. And then finally, we're going to reroute traffic using a service router. And the way that we'll do that, just to recap, as I mentioned earlier, we'll target the product API. We'll say that anything that comes into that API at the /coffee's route or path prefix needs to be rerouted to the destination service of coffee service. Okay, so those are the steps we're going to do. And how are we going to do that? And this diagram illustrates what it'll look like when we're all done. We're going to apply the service configuration. We're going to release the deployment. And then let's go ahead and do that now. And then we'll come back and talk about the service visualization. So first things first, we want to apply the coffee service defaults. So we're going to do that. That's pretty cool. That's done. Pretty easy, right? Kube native, all kubectl apply. And then we'll actually deploy the deployment. Actually, you know what? Before we do that, let's do this. Let's just make sure our service defaults are there, just because I want to show off again our CRD capabilities. Service defaults. There you go. We got a coffee service default that we just registered, and then the front end, the product API, and the public API all had one registered when they were originally deployed. So it's great. So let's go back up here, and we're going to do our V1 deployment. And that looks like it got created. And I've got the OhMyZSH plugin installed. If you don't use that, quick shout out to ZSH and their plugin community. I normally would have to type kubectl get pods, but I can just do KGP with that plugin, and I can see my pods. And it looks like my coffee service is spinning up. It's not quite there. So I'm going to steal another piece of script from my cheat sheet over in another window. Let's go back over here and say, okay, is the service up? There we go. We got 3 of 3 running. So now here in the top center, I'm going to start tailing the logs of that service. And it starts up before the database starts up. So you see a couple of entries about, hey, I can't see the database, and then it can. And then coffee service initialized lets us know that that service is now running. But we haven't routed any traffic to it. So let's go back over to the UI for a second and look at that and see what happened there. So heading back over to the console UI, we can see our product API is still chugging along. Traffic's routing through it as we would expect. We go over to the coffee service, which is a new addition to the services list that wasn't there before. And it's got no metrics available because nothing's running through it, but it does have an upstream of the Postgres defined, right? So it should be able to, we should be able to, if we successfully route traffic to it, it should be able to talk to Postgres. So let's move on from there. And the visualization looked like just like the screenshot that I showed you here. Oh, you know what? I'm going to back up for a second. I want to show you one other cool thing. We're going to apply our router in this window. kubectl apply -f service router. All right, so we're going to apply our router. Created that service router. And what is that going to do? Well, that's going to reroute traffic away from the product API and over to the coffee service, but only for that coffee's route. Now it's going to take a second to catch up here, mostly because I'm running Zoom and Docker and all at the same time. That runs extremely fast. Oh, look, there we go. The failover happened. So all the traffic that was running and hitting the product API for that coffee's route is now getting rerouted over to the coffee service, the version 1 of the coffee service. So let's stop and celebrate that for a second. That all worked, right? Took a couple of seconds because I'm running kind locally and Zoom and, you know, a lot of resources. But if you run this, you know, without a whole lot of things going on in the background, it's pretty darn fast. It happens in sometimes sub-second, depending on your environment. So that was pretty awesome. Let's go, and now let's view it over inside of the console UI, in case that's your default way of observing things. And there you go. Look, our metrics are streaming in. We see that we've got an upstream of the public API now, and Postgres is our upstream. So we had a downstream public API, Postgres upstream. Traffic has been rerouted. And then we can go over here to the routing tab, and look, the splitter and the resolver shows up over here. So that's pretty cool. We've got some more better ways to visualize our service mesh if that's our preferred workflow. And then I want to go back over to the product API, and just as you would expect, traffic has ceased. So that's great. All right, and now, you know, kind of showing the visualization back on our chart. This is the YAML we applied. We said match the coffee's path prefix and reroute it to the destination service of coffee's service. And, you know, clients that call in hit the service router first. The service router says, hey, what path prefix are you going for? If it's coffee's, drop down to the bottom, hit the coffee v1 service, which then can talk to the Postgres database. But if it's any other route, just keep routing it to the products, you know, keep routing it to the monolith in essence, right? So that's pretty cool. However, you might be saying, wow, Derek, that was pretty YOLO. You just like in one fell swoop rerouted all of your traffic from one place to another. You're awfully confident. And the truth is, I did that on purpose with full knowledge, right? We wouldn't want to do that. We'd want to do a canary rollout, right? And we could have done that, but I wanted to give you a quick overview and some instant gratification with the service router. But in part 2 of this demo, we'll go into how to do a canary rollout with our service splitter and service resolver tools, which, by the way, you could have used a service router as well to do a canary rollout. But then my demo would have been shorter. So let's actually, yeah, this is a good time to stop. Let's go back to the UI and take a look. Now that we've done our reroute, let's go to the coffee service, I think is what we want. Oh, I'm sorry, no. The product service, because we applied the router got applied to the product API, right? So you would have to look at its routing tab, and there you go. If this is your preferred workflow, if you like visuals, you can come over to the product API and see how the routing has been applied. Maybe it's 3 o'clock in the morning. Your coffee's not done brewing after your alarm went off, and now you want a quick way to understand what's happening inside the service mesh. That's how you can do it. So, oops, not share. Apologies. I don't know. You want me to share it to you folks? I can send you a link. Put your email in the chat. Just kidding. Let's present again. Thanks for the smile, Jono. That made me feel good. Somebody laughed at my joke. All right, so we took a look at how things are inside the UI. And I'm not going to go through inspecting the resolver and the splitter, right? Because we can do that. I'm sorry, inspecting each one of these CRDs that I deploy, because you can do that on your own. I showed you how to do that with the proxy defaults, and I'll spare you the wash, rinse, and repeat here now. But now we're going to move into the canary rollout phase. And what's involved in a canary rollout? Back to the initial explanation with the config entries, we're going to set up a service resolver so that the service mesh knows what a V1 and a V2 mean and how to resolve them. And then the next thing we would do is we're going to apply a splitter that actually makes the decision to try to reroute traffic from V1 to V2. And then we're going to deploy the V2 service. Finally, that order is important, and I'm going to explain why. The reason that the order is important is because if you were to deploy the splitter, pardon me, before the resolver wouldn't really have an idea of what a subset V2 was. So the service mesh would just start evenly distributing traffic across all versions of your service that are marked coffee service, right? And they do all get deployed as the coffee service. They just have this meta tag of a version, right? So if you were to deploy the splitter before the resolver, then you would inadvertently start evenly distributing your traffic across both versions of your service, which is not what you want to do. So you want to define the resolution or the resolver that knows how to handle a V1, a V2. Then you want to define your splitter. And oh, by the way, when you define your resolver, you define and I'll show you this here in a second with the YAML, you're going to define a default subset. So that's why it's safe to go ahead and put the resolver in place and the splitter in place before you deploy the V2 service, because if the V2 service isn't there to handle its amount of traffic, it'll just fail over to the default, which in this case will be V1. So let's look at it graphically. This is our pre-canary rollout starting state. Okay, things have hit the router. Coffee's traffic is getting peeled off of the monolith. It's getting sent over to the Coffee V1 microservice, which is able to talk to the Postgres database. When we apply our service resolver, this is the YAML that matters, right? Inside of that resolver YAML file, we're going to say, as I mentioned just a second ago, here, this is what a V1 is. Filter on every coffee service pod that has the meta version equals V1 annotation applied, and V2 the same way, right? So once we apply that resolver, our environment's going to look like this. Traffic will hit the coffee's route. It'll get routed. It'll get filtered through the resolver. The resolver will say, hey, there is no V2, so everything goes to V1 because V1's the default. Let's route that over to the V1 coffee service, and then it hits Postgres. Then when we apply the service splitter, we'll put a weight on each one of the services, right? On each version of the services. We'll say send 90% of the traffic to the subset V1 and send 10% to V2, because that, whatever, maybe we would want 97.3 or 99.1, but either way, we split it some way so that we can see kind of what happens when we start routing traffic to V2. But there is no V2 yet, remember, as I mentioned. So everything, that's okay, because we've defined a default as V1, and everything just keeps getting routed to V1 until the service is in place. And then finally, after we run our deployment command, the V2 service will be in place and traffic will start getting routed to it. So let's go over to the command line now and actually put that in place. So what I want to do, I'm going to copy this. I'm sorry. I'm going to copy this log tail command over here, or follow command, I should say. And this is the V1 service. And then in this window, I'm going to start watching the logs. I'm going to get ready for V2 to exist. Let's go ahead and start watching these again. All right, great. Service is up and running. So I'm going to go back over here. And remember, the first thing I'm going to do is apply the resolver. So there we go. And then the second thing I'm going to do is apply the splitter. All right, okay, so that gets created. And again, those can all be, you can do a kubectl get or a kubectl describe on those resources. And then finally, I'm going to deploy the coffee service V2. Oops. And then if I look up here, let me back up for a second. I'm going to take a look at my service name, just because I don't want to do anything with it where you're shaking your head going, what did you just do? So if I get my pods again, again, I'm using that ZSH plugin, I'll see that my coffee service is named V2, right? So that's awesome. Oops. Oops, sorry, wrong buffer. Well, I'm going to port forward from the V2 service. No, I want to do it, sorry, logs. Apologies. SVC, coffee, service. I believe that was -V2. I'm just going to double check. Yep, because I'm live coding, -V2. And let's do that. Oh, is it? Sorry, I might have the, oh, it's a deployment, my bad. Deploy V2. Oop. And we need the container name. Should have gone to my cheat sheet. There we go. And look, it's about a 1 to 9 ratio, right? For every 9 requests that are coming in, 9 of the requests are going over here to the V1 service, and then the 10th request is coming into the V2 service. So that's pretty cool. Let's stop and celebrate that for a second. That happened pretty quick and without a lot of weeping or gnashing of teeth. And if we go back to our console UI, let's go see what we can see. It's going to escape out of here real fast and go back to the API. So now let's go inspect the coffee service and its topology. So the topology is here. Everything looks like you're expecting. traffic's coming in. Go to routing, what happens? Oh, look at that. We've got some new directional lines. And if you hover over them, you can see the percentage of split to each version of the coffee service. So that's pretty cool, right? Like a fast way to figure out what's going on. So yeah, that's pretty exciting. Let's go back here and see what's next. So basically what's next is we're going to iterate through this, right? And I think I'm going to spare you a bunch more slides that are essentially the same diagram with some different numbers. What I want to do next is I want to actually edit my splitter file so that I feel pretty good about the traffic split right now. Things are running. I don't see any errors. Nobody's called me and complained. So let's like update our configuration a little bit and see if we can't, what we're going to do is we're going to change the weights in the splitter file. So let me bring that over here for y'all. So I'm just going to change that to, let's go 50-50. Oops. Sorry, getting a little bit of lag here. All right. A lot of things running. I'm going to save that. Bring that out of screen. So then all I've got to do is come back over here and reapply that splitter config. So I'll do that. Oops. Make sure I'm watching my logs here. And so my splitter has been updated. And in just a few seconds, it'll, oh, look at that. It's reflecting in the streaming logs that you're seeing up in the top two panels, right? It looks like a kind of a 50-50 split, which is what we just defined. And if we go back once more to belabor the point just a little bit, inside the UI, we should, I'm gonna do it. Can't remember. Oh yeah, no, it'll be right here. There we go. 50-50. So that's nice. That's reflective. And then I guess I'm excited. I guess I'm, you know, my services are all working. That feels pretty good. So let's go ahead and set that up to a 0-100 split using, and again, all we have to do is change that same YAML file. And let's change this to a 0 and this to a 100. I'm going to save that. Move that out. Come back over here, apply it again. And cool. In just a few seconds, oh, there you go. Our canary rollout is complete. I would make a couple of suggestions. One would be that when you're done here, what I would personally do is I would probably come over here and delete this particular one and reapply it, right? And I would probably delete this part of the stanza and apply it. And then, but I would leave these artifacts in place because when I want to go do my next canary rollout, right, it just makes it that much simpler. Just come in and add the next stanza, come in and add, you know, and just wash, rinse, and repeat as much as you want to iterate on this microservice. So
one of the things I wanted to point out that you said, Derek, is that this gives developers now the ability to go through and test traffic shaping locally using the exact same process that you would use to update and edit your production clusters. So now if you're following a GitOps style of working where these types of changes would be reflected as PRs, now these get to tie, every one of these changes, once you've tested them locally, you get to tie them back to your environment in code and be able to say, yes, I do know that these changes are good. Yes, I am able to test my traffic shaping locally, and that builds a larger confidence in the type of deployment you're rolling out as well too.
Oh, 100%. Like, I can't stress how much I love the Kind project, by the way. I am just one of those people that likes to do it locally before I'm going to go play on a cloud provider. And yeah, of course, you've got to test out every one of those different environments because there's little, you know, caveats, conditions, and quid pro quos for them all. But 100%, I'm grateful. It's getting incorporated into my CI pipeline. Also, by the way, Kind is a nice tool for that. So yeah, thank you for calling that out. So just to catch us up on the slide deck, this is our first deployment was a 90-10 split. That worked. We went and visualized that inside of the console UI, and we were able to hover over the little directional lines and see that that was actually applied and reflected in the UI. We looked at our network topology, and we saw that our traffic was getting was still flowing through the coffee service itself. We looked at the routing tab. We applied our splitter. Then we updated our splitter to a 50-50 split, and that worked, right? And then we went to the UI and we looked at that, and there you go. It was a 50. We hovered over the graph and we saw that it was also a 50%. And then finally, we updated it to a 0-100. That worked. And then once we did that, this is what our environment looked like. Everything stopped flowing to the 100% to the V1 service and started flowing to the V2 service. The V1 service was still there. And then the final, and then, you know, I left the exercise to the watcher to go in and delete the V1 subset from the resolver. And then the final step is, of course, to delete the service itself. So let's do that just to make sure that doesn't have any bad effects on the environment. So let's delete one. Hold on, let me start these logs here again. Nothing, by the way, nothing's happening in V1, V2. There we go. So we can delete V1. And when it gets removed from the mesh, everything's still flowing. The service, the log tail stops. We go back over to the UI. Let's do that real fast, the console UI. And we should see everything still flowing A-OK. And then, oops, sorry. My machine is lagging just a second here. Sorry about that. So let me go backwards. Well, we'll have to just move on to the next step. The diagram updates, you can see that the V2 service is gone. A little bit of lag there caused me some presentation hiccup, but you get the idea. So let's stop there before we get into next steps. Jono, any thoughts, comments, or questions coming in from the community that we might want to talk about, or do you want to hit next steps first?
So we've had a really lively set of conversations out in the chat. Highly recommend anyone else on the stream to feel free to drop those questions in. Currently, we're all caught up, so feel free to take us through our next steps.
Okay, great. So what I'd recommend is if you haven't been to learn.hashicorp.com, please go. We've got over 400 tutorials there for you on all of our different products, many of which are, you know, a large percentage of which are the Consul Service Mesh product. Should be pretty easy to navigate that. Within Learn itself, a good place to get started is the Consul Kubernetes Production Collection. So it will include our reference architecture document, our deployment guide, and a really good guide for teaching you the internal workings of Consul on Kubernetes. It's called Secure Consul and Registered Services. And that'll give you an opportunity to see sort of, you know, what all the control plane parts are and how they interoperate and how to secure them and how to turn security off if you need to debug things. So it's a really good starting point for both developers and operators or people who serve a hybrid role. If you're interested in learning more about Consul and Kubernetes, I highly recommend you check out the HashiCorp Cloud Platform collection that's on the Learn site. There's also, as I mentioned earlier, when we went over the service intentions, custom resource, or pardon me, config entry. If you check out that manage Consul Service Mesh using custom resource definitions, it will show you how to use those service intentions to secure your services at a layer 7 using headers and query strings, etc. Also, one that's been really gaining popularity lately is layer 7 observability with Consul Service Mesh using Prometheus, Grafana, and Kubernetes. That We'll tell you how to install the Prometheus operator into the service mesh, install Grafana. It'll give you some basic overview of how to look at what metrics are available within Prometheus, and then how to view them and within Grafana and change your queries, et cetera, like that. So some of this information, honestly, is now available within the console UI visualization and metrics. And so it's going through an update now to show you what you can see within console itself. Also, another big interesting thing I want to just point out is a developer at our company, Kit Patella, has recently published a Grafana dashboard for console metrics that is now a free and open source tool that you can download from the Grafana dashboard portal and just import it by ID. It'll all run. You'll be able to see metrics. It's pretty sweet. And then also I would point you towards the HashiCorp Consul Service on Azure collection. It and the HCP collection, they're going to tell you ways that you could use a managed service either on the HashiCorp Cloud platform or on Azure to run the control plane for you. And that just sort of eases the burden of operating a service mesh because you're just responsible for the data plane and the client configuration. So those are all great resources to learn more about how to use this for your company. Maybe running it yourself isn't the right option, or maybe it is. And that's one of the great things about Consul is it's extremely versatile in its deployment options. And then I'd also encourage you to head over to the HashiCorp YouTube channel and check out all the deep dives we did this week here at KubeCon. We had my good friend Cody DeArkland and DevOps Jackie did a waypoint workflow in a Kubernetes world deep dive that is super cool. If you're not familiar with Waypoint, please go check it out. I'm very excited about that project, and I hope to be publishing some content soon on how to use it with Consul. My teammate David Yu also did a deep dive with Rosemary Wang, I think yesterday, or Wong, pardon me, on multi-cluster service mesh with Consul on Kubernetes. And all that's available at the HashiCorp YouTube channel. So thanks so much. If you want to reach us, you can, my specific team, which is again the education team, we write the content on Learn. You can reach us at consul-education@hashicorp.com. And you can also visit the learn.hashicorp.com website. I want to point out that all of our tutorials should have a feedback section at the bottom. If you finish any one of our tutorials and you want to give us praise, please do. If you want to let us know something didn't work, we want to hear that too. We want to give you the best possible user experience we can. And we really, really take it to heart when people leave. That's the best way to affect what you see on the Learn platform, is to give feedback directly through the tutorials. And with that, I think that's the end of my presentation, Jono. I went a little fast there.
No, you finished right on time. So with the final minutes that we have, I want to take a moment to say thank you, everyone, for spending time with us on today's stream. We know it's been a long week of sitting at a computer and taking in all the information that KubeCon provides. And so we thank you for spending time on your Friday with us. If you want more HashiCorp news, please feel free to join us today on Twitch at HashiCorp Live. That's Twitch TV/HashiCorp Live, where we're going to be discussing what it's like for a developer to go through and create a Terraform provider, as well as the new plugin for the features and functionalities within the SDK. So for all things Terraform, go ahead and take a look at our HashiCorp Live on Twitch today. That'll be at 1 p.m. Pacific, 4 p.m. Eastern, and we invite you back. If you have questions, comments, or concerns, please feel free to raise them on our forums, discuss.hashicorp.com. And for everyone who's watching this after the live stream, check out the links below in the description, where we'll be posting the links that were provided in the slides. And with that, thank you all for the time and for joining us, and have a wonderful weekend. Yeah.